Good morning, my dear students. My name is Sharma, working as physics lecturer in one of the reputed institution. Today we are going to know a very important concept, one question guarantee for any competitive exam, that is about dimensional analysis. Okay, so before going to know about dimensional analysis, let us take some small examples. So here two man-eaters are carrying a leopard and a person selling fruits. Here they are carrying some rice bags. Here carrying some fruits. One selling apples, another one selling jackfruits. Okay, so if you notice, rice bags, mass measure, no? Flesh. In that case also you measure mass. Fruits, you measure mass. So whether it is fruit, rice or flesh, all the quantities are nothing but mass only. Because this is measured in kilogram, this is measured in kilogram, measured in kilogram. So dimensionally, any mass, increasing mass or decreasing mass, any type of mass measured in kilogram. So that is why dimensionally mass always represented with capital M. So what is the dimension formula for mass? Capital M. So why we employ this method? Mainly giving units to all physical quantities. Okay, so the main purpose of this dimensional analysis. Okay, the main purpose of dimensional analysis is to give units to all physical quantities. Okay. Now about second example. So here a Thor and an elk are standing, okay, and they are applying force on a man. So he is applying muscle force, whereas he is applying some mechanical force through hammer. So what do you notice in these two examples? So whether it is a muscle force or a gravitational force or an electrostatic force or magnetic force or a mechanical force, dimensionally it is only treated as force. So any force is taken same dimensional formula. So dimensional formulas are mainly to give units to all physical quantities, but they will not tell us completely about the physical quantity. So it is a force, we can conclude. Now here a Japanese girl drumming and another countryman is drumming. So both are drumming and gives sound, no? Both the instruments are giving sound. So that sound energy is measured in decibel. Okay, so intensity of sound. So like this, there are too many physical quantities like power, area, volume, pressure, right? Surface tension, viscosity. So there are too many quantities to measure. So that is why in order to give units to them, we are using a technique called dimensional analysis. So mainly dimensional analysis will help us to solve problems easily, that is by knowing their units. Okay, once we know the units now, it is easy to solve any problem. So that is why remember two important points under dimensional analysis: length, radius, okay, depth, height, all measures distance between 2 points only, no? So they are taken as L. Mass, any mass represented by M. Time, T. Any force, F. So taken in terms of M, L, T. So usually in the dimension formula you take the physical quantity in terms of M, L, T. Now based upon this dimensional analysis, now we are going to solve some problems. Now force is given as AT plus BT square. Okay, so you want to find dimensional formulas for A and B. So unless these two are forces, we cannot find A and B. So it is called principle of homogeneity. Unless two physical quantities are same, we cannot add or subtract. Okay, so this is equal to force, this is also equal to force. Now, so F equal to AT, okay, F equal to BT square, right? Force, mass into acceleration. Okay, it's a dimension formula, mlt power minus 2, which is equal to A into T na, then A becomes mlt power minus 3, right? Now next one, force mlt power minus 2 equal to B into T square, right? So B becomes mlt power minus 4. Okay, so in this way easily we can solve problem. So remember, over here we are using principle of homogeneity. Unless the two physical quantities are same, we cannot add or subtract. That means it is force. This is also force. Okay. Now, velocity of a body is given as AT plus B by T plus C. Okay, so that is your given problem. Where T is time. So unless the two quantities are velocity, we cannot add or subtract. No, so that is why we equated to first AT, next V equal to B by T plus C, right? Now about velocity, dimensional formula for velocity is LT inverse, which is equal to A into T, right? So A equal to L T to the power of minus 2, that is by sending this T to other side, right? Now about next one, B by T plus C now T plus C, that means unless C is time, these two cannot be added, no? So that is why C straight away taken time, right? So it is nothing but B by T. Why? T plus C you have given, that means C also must be time, because you can add time to time, no, but you cannot add time to length or time to mass. So we know unless two physical quantities are same, we cannot add or subtract. So velocity LT inverse which is equal to B by T, right? Take this to other side, LT minus 1 plus 1 equal to B that means B becomes only L. Okay. Now about the given problem. In this problem you have given displacement of a body is given as A by B of 1 minus E power minus BT. Okay, so you want to find dimensional formulas for A and B. So if you notice, there is one exponential function you have given. So remember, dimensionally exponential function, trigonometric function or else logarithmic functions have no importance. That means directly we can equate them to 1. Okay, over here E power minus BT so I am taking BT equal to 1. Okay, so T time. So it is 1 by T. Nothing but T inverse. Okay. Now about A. So this whole thing is taken as ratio. No importance. No. So S is equal to A by B. Right? When S is displacement now, according to problem, S denotes displacement. So dimensional formula for displacement is L equal to A. You have to find, let it be A only, but B is T inverse, right? So A becomes LT inverse. So what is the dimension formula for A? LT inverse. Okay. Now according to problem, the measurement of units in two system is 2:3, like CGS to MKS or SI to some other system. Mass ratio units, length ratio units, time ratio units is 2:3. Then you want to find angular momentum. No? So angular momentum is given as MVR, right? So suppose if you are unable to know the formula for dimension formula of angular momentum, use normal formula MVR, right? So M mass na, so dimensionally it is denoted by M. Velocity LT inverse. Radius is also length na, so that is by L. So nothing but ML square T minus 1. So now you want to know ratio of units of angular momentum, right? So M1 by M2. Okay. Next L1 by L2 whole square. T1 by T2 power minus 1. No? So this ratio or these two quantities ratio units, this also 2:3 according to problem, right? So 2 by 3, okay, 2 by 3 whole square, 2 by 3 power minus 1. Okay, so whenever bases are equal, powers are added, no? 1 plus 2 minus 1 cancelled, right? You get 4 by 9. So what is the ratio of units of angular momentum in those two given systems? 4:9. Okay. Now about the given problem. So unit of force given as 10 Newton. Okay. Power 1 megawatt. Okay. Time 1 millisecond. Okay. So you want to find unit of length. So here you have given some multiples also. Mega, 10 power 6. Milli, 10 power minus 3. Okay. So time known, power known, force known, you want to find length. So some of the problems without using dimensional formulas also we can solve. How? See, power is equal to work done by time. No? That can be taken as force into displacement by time, right? So why I am taking in terms of F, S and T according to problem, power known, force known, time known, you can find displacement. So according to problem, power, 10 power 6 equal to force 10 Newton into displacement you want to find, let it be as by T 10 power minus 3. Okay. So 110 cancelled na, 5 left. Cross multiplication. So displacement S is equal to, okay, 10 power 5 into 10 power minus 3. Nothing but 10 square. Now you have to know units. So all are in SI system na. See, force Newton, power watt, time second. So it is also in SI system means 100 meter. So displacement is equal to 100 meter. Okay. Now about the given problem. So in one system of units, power value given as 200 watt. So you want to convert in the other system. Okay. So whenever you want to find the numerical value in the other system, first we should know the relation between numerical value and unit. So let us take one example. You see 100 centimeters is equal to 1 meter now. So centimeter is in CJ system, meter is in SI system. So what do you notice? That is, numerical value is always inversely proportional to units. So this product everywhere it is constant. So N1 U1 is always equal to N2 U2. Remember, okay? So dimensional formula for power, work done by time now, work done, force into displacement by time. No? So force, mass into acceleration. Displacement by time, velocity now. So it is ml square t power minus 3. That is the dimensional formula for power. No? So if you know this, easily you can solve the problem. Okay? So m L square t power minus 3 in one system. Now units is equal to in the other system. Same quantity, but they said mass is doubled. So instead of m1, we are writing 2m1. Okay, length is halved. That means L1 by 2 na. Power square. Time is also doubled. So you can take 2t1 power minus 3. Okay. Units. Okay. Now 2 1 by 4 2 power minus 3. First you always take the multiples. 2 into 1 by 2 square into 2 power minus 3 of formula m1 L1 square t1 power minus 3 units. Okay. So 1 2 cancel now. 1 2 cancel. You get 2 power minus 4 na into power units you want to find na. So 1 by 16. No, this value you have given 200. No, so 200. No, 1 by 16. So power units in the new system is 1 by 16 into 200 na. So nothing but 3200 units. Okay. In this problem, pressure, velocity and time are taken as fundamental quantities. So you want to find force in terms of pressure, velocity, time. Okay. So according to problem, force must be taken as in terms of pressure, velocity, time. Okay. So now about pressure formula. Force by area na. force, mass into acceleration. Area L square now. So power 1L cancelled. M L power minus 1 T power minus 2. Okay. So now we can substitute all these formulas. Force, mass into acceleration. Okay. Pressure, M L inverse T power minus 2 na power A. Okay. Velocity, velocity LT inverse na power B. Time, it is M power 0, L power 0, T power 1 whole power C. Okay. Now M power A. This one 0 na, plus this is also 0. Right? Equal to M power 1. Means it is very clear that M power A is equated to 1. Right? So whenever bases are equated, powers are also equated. No? A becomes 1. Now about next quantity. L minus A, okay, plus B. No? So L power 1, right? So you can take directly minus A plus B, right, equal to 1. So A already known na, so B becomes 2. Okay, A1, B2. Second option is right, but still if you want to know the other value, okay, so next about C means T power, right? So T power, okay, T power minus 2A, okay, minus B plus C. Okay, so this T power is directly equated to T power minus 2. Okay, so minus 2A, okay, minus B plus C equated to minus 2. Okay, or else you can take A1, B2, C2, substitute. If you get minus 2, so also you can take directly option. No? So, he already known 1, B2, C you have to find, right? So, minus 2, minus 2, minus 4 now, take to other side, plus 4, so C becomes 2. That means first option is the correct one. Okay, so instead of solving, by substituting also A1, B2, C2, otherwise A minus 1, B2, C minus 2 also you can find. Now about the given problem. Young's modulus, surface tension and time are taken as fundamental quantities. So you want to find formula for density. Like previous problem, in this problem you have given density. So density must be represented in terms of Young's modulus, okay, surface tension and time. Okay, so Young's modulus, stress, pressure, all these are having same formula. Young's modulus, of course all of you know it, stress by strain. Strain anyhow dimensional less, no? So I am taking directly stress. Force by area na? So force mLT power minus 2. Nothing but ml inverse T power minus 2. So remember this Young's modulus, stress, pressure, all these are having same dimensional formula. Density, of course all of you know it, mass by volume na, so ml power minus 3, right? T power 0. Next, Young's modulus, ml inverse T power minus 2 power A na. Next about surface tension. You know surface tension, force by length na. So surface tension and force constant have same dimensional formula. Force by length. So mlt power minus 2 na by L cancel. Right? So it is nothing but m L power 0 T power minus 2 power B T time only now. So m power 0 L power 0 T power 1, right? Power C. Okay. Now m power A plus B plus 0, right? L power minus A, okay, 0 plus 0. Next T power minus 2A, okay, minus 2B minus C. Okay, so it's very clear. L power minus A straight away you can equate to minus 3 na. That means L power minus A equal to L power minus 3, right? So A becomes 3 na. So now check these options. Okay, A value is 3. Okay, so order wise Young's modulus we have taken first, but in the formula you have given the surface tension next, right? But in this surface tension given first. See A order 3. So in these two A 3. According to us Young's modulus we have taken first. So y power 3 confirm. So answer is in between these two. Okay. Next, if you know surface tension means B value also we can easily find. Okay. Now about B. How you know A plus B 1 na? He already known 3 plus B equal to 1, right? So B is minus 2. That means surface tension power must be minus 2. So surface tension power minus 2, Young's modulus power 3. That means you need not solve C also. By looking at the options we can say the third one is the correct one, right? So in this way easily you can solve any problem by sometimes verifying with options also. Okay, if you like this video please subscribe, like and share. Thank you.